This is video number 1 for sections 7.1 and 7.2, finding the equation of a parabola in vertex form. Last time we talked about the vertex form of a quadratic function, which looks like this. And we said if somebody gives you an equation like this, you know an awful lot about the parabola just from looking at this equation. For example, the h and the k, those two numbers, they tell you the coordinates of the vertex. Remember, there's that built-in minus that you have to take into account. And then the A tells you both something about the direction and the shape of the parabola. Direction meaning does it open up or down, and shape meaning is it kind of wide or narrow. Well, in this lesson and in this video, we're going to talk about how do you go backwards. What if somebody gives you some information about a parabola and you want to write its equation? For example, this problem says find the equation of the parabola that has vertex 2 comma negative 1 and that goes through the point 5 comma negative 4. It turns out that as long as you have the vertex and a point, you can easily find the equation of the parabola. Let me begin by jotting down again that vertex form. All I need to do is figure out the A, the h, and the k. Those are just numbers, constants. And if I can figure out their values, I stick them in here and I'm done. Well, I'm sure you're seeing that I'm mostly done right here at the start, because if they give me the vertex, they're essentially handing me the h and the k. The h is 2, the k is negative 1. I can immediately fill those pieces in. Not sure about the a yet. H is 2, so I have x minus 2. K is negative 1, so plus negative 1 would be minus 1. All that's left is for me to figure out the value of A, and I'll be finished. Well, think about what we've done so many other times this semester. When we've been trying to find the equation, we have one constant left. We know a point that's on the graph. It's that temporary plug-in idea. This is just some random xy point that's on the parabola. Well, I can use that point temporarily. I say temporarily because, of course, we're going to go back to x and y in the end. But if I plug in my values for x and y, the only letter remaining here is the a, and so I can work out the math and solve for a. Let's see, how would I do that? Hopefully you realize this piece here, you might be looking at this and go, oh, it's a FOIL problem. That would really be overkill. These are just numbers, so there's no reason to do anything except just follow normal order of operations. 5 minus 2 is 3, and 3 squared is 9, and a times 9 would be 9a. So don't do anything overly fancy there. And there's just a few basic algebra steps, and we will have it. Divide both sides by 9. And it looks like I end up with a equals negative 1/3 when I reduce that. All that's left is for me to fill in my pieces. We've got an a is negative 1/3. We already knew the vertex was 2 and negative 1. Don't forget the squared there. That's what makes this quadratic. Here then is my final answer to this problem. This is the equation of the parabola that is being described. This process can be used anytime you are given the vertex and one other point. Later in the chapter, we'll talk about how we can deal with a situation where we're not given the vertex. All right, well, let's take a look at this next example. We'll use this same skill, but this is more of an application. It's a scattergram problem. The scenario is defense spending. So here we've got the let statement. F of t stands for the amount of money spent on defense. I think this is national defense in billions of dollars. T is the number of years since 1990. I think this is actually real data here. As usual, letter A says we may have to adjust the data to match the variable definitions. I think the money information looks great because it's already in billions of dollars, but the years, we always have to change those. Let's see, we're measuring years since 1990, so let's go ahead and change all of those numbers. And then now that we've adjusted those year numbers, we can go ahead and go over to the calculator and draw a scattergram. We'll try to go through this quickly. Remember, we hit the Stat button and then choose Edit. If you have old data up there, you're going to have to hit Clear and Enter on the name of the list. And then just enter the data from the handout. I've got the T information in my first column, and I'll put the money, the F of T information in the second column. Okay, and once that's all in there, then I need to go to the y equals area and turn on my plot. Let me go ahead and get rid of anything else that I have in there. I'll go up to plot 1, hit enter to turn it on. Now it's highlighted. And then zoom 9 gives you that nice window. And we've got the scattergram. And the handout says, what type of function should we use? I'm sure you're not shocked. Since we're in the quadratic function chapter, our dots kind of look like a parabola. You can see that there was this trend of going downward and then upward. It's that typical parabola shape. So we'll use a quadratic function to model this situation. The handout says to go ahead and find an equation of that model, and there's a note that says, look, the only way we can do this, at least right now, is to pick one of these points to be the vertex, and then use one other point to try to find the A in the equation. Well, if you have to pick one point to be the vertex, there's only one choice. You need to pick the lowest point. It is this third point right here. So that definitely is the one I need to use for the vertex. What other point should I pick? Well, I'm thinking that I should probably pick one of these up top here. If I pick one of these two over here, I feel like I'm going to get a really shallow parabola, one that doesn't really summarize the whole pattern. So I'm looking at this thinking maybe that second to the last one might give me a reasonable picture. I'm not going to get something perfect here. I'm just looking for something close. So let's use the third point and the sixth point. Okay, so back on the handout then, we decided we're going to use this third point to be the vertex, and we're going to use this sixth point as our extra point that we need to find the A value in the equation. We just need now to start cranking out the work. I'll list my vertex form again. And I'll fill in the vertex, the 8, 268. That just means in 1998, we were spending $268 billion on defense. Now the only thing I don't know is the A. Here's where the temporary plug-in idea comes in. We decided to use this 17,551 point, so let's stick that in. Remember, I'm temporarily filling in the X and the Y so that the only letter left is the A, which I can now solve for. Again, I have that parentheses over on the right side. Don't overthink that. 17 minus 8 is 9, and 9 squared is 81, so that's A times 81, or 81A. And then I just, again, have kind of the simple algebra to finish this thing off here. And that gives me 283 on the left. And then divide by 81, and we've got our A. We've been saying in this unit that we're happy to work with decimals instead of fractions, so let's get a decimal version of that. And I got A as about 3.49, rounded to a couple of places. Pay attention in my math lab for rounding instructions. All I have left to do is to write down the final equation now. Let's see, they want me to use function notation, and they want me to make sure I use the correct variable. So if you refer back to the let statement, I think our x variable was t, and our function name was f of t, and so that gives me this final equation. You can see the vertex in there, the 8, 268, and you can see that a value that we just found. Well, let's go ahead and add this to our scattergram and make sure that everything looks okay. I'll need to go back to my y equals and type that equation in. I'm going to leave the plot on because I would like the scattergram to remain. So let's type in the equation. And once I've got it in there, I just go back to the graph, There's the scattergram, and there comes the quadratic function. And that did about what I figured it would do. You can see it goes right through that vertex. It goes right through that sixth point. It comes pretty close to all of the points. Maybe a little bit too far away from this guy here, but still a reasonable job of describing the overall data. Let's wrap this up by using this model now to answer a couple of questions. The next question says, find the y-intercept of this particular model and then explain what it is that we've found from a real-life standpoint. Well, you find y-intercepts the same way no matter what kind of function you're talking about, and that is by replacing the x with 0. In this problem, t is our x, so essentially all I need to do is find f of 0. Replace all those t's with a 0. Let's see, in terms of working this out, again, don't overthink the parentheses there. 0 take away 8 is negative 8, and if you square negative 8, you get positive 64. And then just reach for your calculator, and I think we're all done. I got about 491. As far as the real-life meaning, it might help to write it as an ordered pair. We're saying the y-intercept is 0, 491.36. We'll go back to your let statement. T stands for number of years since 1990, so the 0 would mean we're talking about the year 1990. The f of t, the y value, stands for the money in billions of dollars. So we're essentially saying in 1990 we spent 491 billion on defense. I have no idea if that's actually true. We're just saying that's what our model predicts. Okay, and then finally, letter E, according to your model, how much money will be spent on defense this year, meaning 2017? Well, let's see, I have to think about my let statement. T was number of years since 1990. If I subtract that from 2017, that comes out to be 27 years. Obviously, if you're watching this video in a different year, then you would have to make an adjustment. All I need to do is plug 27 in for t and work out the math. You don't even have to work this out in pieces. I mean, you can just type this all into your calculator in one step, just like it's written. And you should get about 1528. What are we trying to say here? Well, we're saying that if this model holds true, that this year we would be spending $1528 billion on defense. And that's a fine way to give the answer. Probably the more normal way to describe this number would be $1,528 billion. And again, we'd have to do some research to see whether or not